Hi class, we are going to start chapter 10 today, starting with section 10.1, the geometry of solids. There are going to be a lot of definitions, so you will have to pause this video frequently in order to get the notes into your electronic notebook. So make sure that you put me on pause when you need to. Okay, so section 10.1, the geometry of solids. So, in the last section in chapter 8, section 8.7, we made some of these solids, prisms and pyramids, and talked about them. So now we're going to define and look at these more closely. All of chapter 10 is on volumes. So instead of looking at the surface area, we are going to be finding the volume of all of these figures. So the first definition is for a polyhedron, which is a solid formed by polygons that enclose a single region of space. So a polyhedron could be a prism or a pyramid. So both of those go under the big heading of polyhedron. The faces, which we've talked about a little bit already, are the flat polygons that make up the polyhedron. Edge is the next definition, and edge is this line segment where two faces intersect. So an edge of this cube, one example would be there. So any line segment where the two faces intersect will be referred to as an edge. Now we're going to look at specific polyhedrons. A tetrahedron is a polyhedron with four faces. Just a total of four faces. If you look at the picture here, hexahedron is this first picture. There are 6 sides. Heptahedron, that means all of these have 7 sides. And a decahedron will be a polyhedron with 10 sides. A regular polyhedron, which you could probably guess, is if all the faces are congruent. So just like a regular polygon, except for now it's 3-dimensional, so it's a regular polyhedron. So all the faces of a polyhedron are congruent polygons. If you look at these pictures, these are all prisms. They are rectangular prisms if the top and the bottom are rectangles. Triangular prism if the top and the bottom are triangles. So look here, we've already looked at these some. Remember, our lateral faces are rectangles. So remember, we called these lateral faces. they are rectangles. And the top and the bottom, which are the same, are our bases. And then a hexagonal prism, now this isn't a right prism because it's not perpendicular to the base, but the top and the bottom are still hexagon. There's your lateral faces here, and then our lateral edges. So let's define our prism. Again, we've already talked about these. We are only going to look at right prisms. So this is not a right prism. Because the height is not perpendicular, or the edges, I'm sorry, are not perpendicular with the bases. So if the edge is not perpendicular, then it's not right. So we're going to look at right prisms. So all of our faces are rectangles, and the edges are perpendicular to the base, whatever the base figure may be. When it's not a right prism, like the one drawn here, it is called an oblique prism. So the edge is not perpendicular with the base. Pyramid. So we made some pyramids back in chapter 8. Here's a pretty picture of a pyramid. They are also classified by their bases. The altitude is the perpendicular segment from its vertex to the plane or the base. So this here is the vertex. It's shown in this picture here. So the altitude is where it hits perpendicular to the base. So that's the altitude. In a pyramid, let's talk about a right pyramid, not oblique. So like this one is oblique. We are not going to study the oblique ones. We're going to look at the right pyramids. The lateral faces are triangular. And the altitude let's say the altitude's endpoint is the center of the base. So this point right here, because this is right, that is the center of our hexagon on the base. This square pyramid here, if I draw in the altitude, that endpoint would be the center of the base of the square. That's how you can tell if it's right or not. Again, we're only going to study the right pyramids. Here is a picture of a right cylinder. The altitude, again, is perpendicular with the base and is in the center of the circle. And this here says axis, I would call that altitude. It will also be the height. Probably would not be a bad idea for you to draw that in here. The length of the altitude will be the height. altitude, the length of the altitude is still the height of the pyramid or the prism. Here on the oblique cylinder, you can see where they've drawn in the altitude, and the one that's drawn in the cylinder is not perpendicular to the base, so that's what makes it oblique. Here's your right cone and your oblique cone. You can just see the difference there. And then we have a few more definitions. A sphere, you'll think of a soccer ball, a tennis ball, any perfect ball is a sphere. Earth is a sphere. So the definition is the set of all points in space at a given distance from a given point. That's what makes it a perfect sphere, is because they're all equal distance from that center point. A hemisphere is half of a sphere, and the great circle is the circle that encloses the base of a hemisphere. Also, real quickly, want to talk about the 5 Platonic solids. These solids, as you see here, we're going to talk about each one specifically, are the Platonic solids. Take a minute and read that. The first one is the tetrahedron. These are definitions that you want to get into your notes. 4 equilateral triangles. Then the hexahedron, made by 6 squares. The octahedron, 8 equilateral triangles. The dodecahedron is bounded by 12 equilateral pentagons. And then the icosahedron is bounded by 20 equilateral triangles. Euler's formula, the relationship between the vertices, edges, and faces of any polyhedra is V for vertices, so the number of vertices plus the number of faces will equal the edges plus 2. We're going to talk about this some more in class tomorrow, but I want you to get those definitions into your notes and know this formula. And the name is Euler, not Euler, but Euler. So we want to pronounce it O-I-L-E-R, Euler's formula. I will check all of these notes tomorrow in class. So here's some examples of Euler's formula. I will check your notes, and then I will also check that you have done the mini investigation number 36 on page 526. I'll see you in class.